Alright guys, welcome back. We're going to be solving another question from the first chapter of the Johnston textbook, Mechanics of Materials, and we have question 11. And for this bridge truss, we have some loading as we can see in the figure, and we need to determine the average normal stress in member BE, knowing that the cross-sectional area of the member is 5.87 inches squared. So basically what we have in here is that we have the area of the member BE, which is 5.87 inches squared, and we are asked to find the average normal stress on BE, which all we need to do in here is to find the force in BE and divide that by the area of the BE. We already have the area, and all we need to do in here is to find the force in member BE. So looking at the truss, we'll see that we have some unknowns. We have two different supports at point A and H. If we look at the A support, we can see that we have a fixed support, meaning we have both X and Y components, and we have a roller at H, which means it can rotate freely in X direction if we call our X and Y in this direction. So we'll have a normal force, which we can call it H. In here, no X components, since we are neglecting the effect of friction, so it can move freely in X direction at the H support. So since we are in equilibrium, we can do our equilibrium equation where we have sum of all forces equals 0 and sum of all moments equals 0. So our F will have sum of all forces in X direction is equal to 0, but the only component that we have in X direction is AX, which means our AX is 0, and we're going to do the same thing for Y. And in order to find the unknowns that we have in here, we can do our moment equation. Let's do the moment about point H, then we can get rid of the unknown that we have at support H. So we'll end up with the moment of AY, which as we can see, it's going to be a counterclockwise. It's going to be a clockwise moment, so we have minus AY times the distance that we have, which is basically what we have from here to here. So 9 times 4 feet, and we have the moment of the 80 kips force that we have about point H, and as we can see, all of them are counterclockwise. They just have different distance to point H. So let's start with the first one. So all of them are positive 80 since they are counterclockwise, so 80 times what we have from H to C, which is 9 times 3. We also have the force at point E. The distance is 9.2. By the way, we are using the 2D shortcut that we have for finding the moment in 2D, which is basically we have all the forces. We need to have all the forces in X and Y direction. As we can see, all the forces are in Y direction, and the vertical distance from the line of action to the point that we are trying to find the moment about, which is point H. So the vertical distance is what we have from here to here, from here to here, and from here to here. These are all the vertical distances that I'm talking about. And also we have the last one, 80, that is applying at point G, so 80 times 9. And this will be equal to 0, and from here we can find the only unknown that we have in here, which is AY, and we're going to get 120 kips at point AY. So now that we have the AY, we can use our method of sections for solving this. We are interested in finding the force in BE, so if we do our section in here, it's easy enough to figure out the force in BE, and let's see how we can do that. So I'm just gonna draw the free body diagram in here. We have AY, we have 180 kips here, and by the way, we know our AY is 120, and we have two different forces in here. We can call this one FBD and the other one FBE. So if we look at the Y component and sum of all forces in Y direction, we see that we only have one unknown in here, which is the FBE. FBD is already in X direction. We already have AY, and we know the other one is 80. So we should be able to figure out the FBE in here easy enough. But first of all, we have to have some information regarding this angle here. Let's call it theta, which is the angle that we have in here. We just have to figure out how we can find this angle theta. But if we look at this triangle, this right triangle here, we have the adjacent 12 and we have the opposite 9. So if we do the tangent of theta, we can find the theta easy enough. So if we do the tangent of theta, we basically have the opposite, which was 9/12. So the theta would be the tangent inverse of 9/12. And if we calculate this, we're going to get our theta 37 degrees. And let's get back in here and find our Fy. So basically we have Ay, which is 120, and this will be the positive direction for our y, minus 80 minus the y component of FBE, which will be basically FBE times cosine of theta, which is 37 degrees, equals 0. And from here we can find FBE 50 kips, and that's all we needed to find in here. Now that we have FBE, we can find our average normal stress, which was basically 50 divided by the area. If we get back in here, we have the area of 5.87, and that's going to give us 8.52 KSI, or what we call, so we have kips in here over inches squared, which is going to be our KSI. And this would be the final answer for this question. I hope you guys find this one helpful. Let me know if you have any questions. Don't forget to subscribe to the channel, like and comment. It's going to help me to reach out to more students. And you guys take care. I'll see you in the next video. Have a good one.